Transfection is the process of delivering nucleic acids into eukaryotic cells while minimizing unintended effects such as toxicity, off-target gene perturbation, or cell death. Because nucleic acids are hydrophilic molecules and the cell membrane is hydrophobic, coaxing DNA past the membrane can prove challenging. Transfection can be accomplished by a variety of techniques, such as lipid-based transfection, or transfection using calcium phosphate, or electroporation, the use of electricity to transport DNA into the cell. This animation focuses on lipid-based transfection, where the cationic head group of the lipid compound associates with the anionic phosphates of the nucleic acid. This method is suitable for transient as well as stable transfection, achieves high efficiencies, and works across a broad range of cell lines. DNA is a hydrophilic molecule and cannot pass through the hydrophobic cell membrane. Lipid-based reagents associate with the DNA, creating a lipid DNA complex that can pass through the cell membrane, either by endocytosis or by fusion with the plasma membrane. Cell lines differ in how they are affected by transfection reagents. Established or lab-specific cell lines may have existing protocols that work well, thus saving someone new to transfection the work of optimizing the transfection conditions. However, new or unfamiliar cell lines may require optimization for successful and efficient transfection. Transfection optimization is accomplished by setting up a matrix in a multi-well plate to determine the conditions that result in the best transfection efficiency, gene expression levels, and highest cell viability. The lipid-to-DNA ratio and DNA concentration can be varied across the rows and columns of a multi-well plate. Additionally, the length of time for transfection, a variety of lipid reagents, and incubation time for lipid-to-DNA complexes may be addressed. When setting up this matrix, you are creating a variety of lipid-to-DNA complexes to find one that pairs well with the cell membrane. A stronger net positive lipid-to-DNA complex charge may lead to greater transfection efficiencies. Optimization will ensure that cells are transfected using the best possible conditions. Once DNA is successfully transfected into cells, you can perform ELISAs and Western blots, luciferase reporter gene assays, comparisons of promoter strength, and protein production studies using transiently transfected cells. Most transfections are transient, meaning that the DNA remains in the cell cytoplasm and does not integrate into the cell's chromosomal DNA. Transiently transfected cells will lose the introduced DNA after a few cell divisions, whereas stably transfected cells will continue to express the introduced gene. Stable transfection means that the DNA has been incorporated into the cell genome and will persist in daughter cells. Stable cell lines are generally useful when an assay or task will be repeatedly performed and consistent performance is needed.